All right, so last time we were in the middle of section 1.3, so we're going to finish that up, and then we'll take a look at 1.4. So this is kind of a review. Let's graph 16x minus x cubed, and I just want to find the domain and range. Okay, so remember, domain are the numbers you are allowed to plug in. Two things you want to be careful about is making sure you never divide by 0, and you never take the square root of a negative number. Okay, actually, before I even type that in, do I have any fractions here with letters in the bottom? What do you think? Yeah, Anthony? No. No fractions with letters in the bottom, so I don't have to worry about dividing by 0. And do I have any square roots in that problem? No. So the two things that could be issues to finding the domain, they're not in this problem. If there's no issues with the domain, does anybody remember how we say what the domain is? Yeah.
All real numbers?
Yep, all real numbers. And if the domain is all real numbers, that means the lowest number you can pick is negative infinity, and the highest number you can pick is positive infinity. Okay, remember last week we talked about, I think we talked about the brackets and parentheses, right? Did we talk about those two symbols? So remember, the bracket means that you can include the value. Parenthesis means to not include. Infinity always gets a parenthesis because you can't include it. You can't reach it. So remember, this is the low value, and this is the highest value you can pick. And when you use infinities, that means you can pick anything you want. Okay, let's graph it and look at our range. Now, at some point, this graph turns. Is that a good window for seeing where it turns? No. I've got to set my y max and min higher and lower. I'd try like maybe negative 60 to 60. Just to give me a little bit more zoomed out look. There we go. Now we can see where it turns. How high does it look like that graph is going? Anybody have a guess?
Oh, you mean like how high the
Yeah, how high up it goes.
infinity?
Infinity, it's just going to keep going up. It's never going to turn again. And how about how low it goes?
Infinity as well.
Negative infinity.
Negative infinity, yeah. So the range happens to be the same as the domain. That doesn't always happen. So the lowest, comma, and the highest. Any question on that one? I think I've got another domain and range. Let's try this one. Oh, no, actually that was the only one. So any other question before I move on from the domain and range? Okay. So we're going to do lots of different problems with rectangles. Sometimes it'll have to do with the perimeter of the rectangle, sometimes the area. This one's going to have a little bit to do with the area. So we've got a rectangular pool that has dimensions of 30 by 50 feet. We're going to put a sidewalk around the pool. It's going to be the same width all the way around. My goal is going to be to figure out what the width of the sidewalk is based on what they tell me. All I know is the area of the sidewalk. So So the area of the sidewalk around the pool is 600 square feet. That's enough information to figure out the width. So the first thing when I look at that, I see lots of words, lots of statements. What would make all of this easier to kind of be able to see what's going on if we did what?
Take our notes.
If we what?
Take out our notes. Take out like the 600 feet out.
Okay, so yeah, looking at all the numbers, that's going to be important. So focusing on the important things there. What else would really help us to see what's happening here? Yeah.
Turning it into an equation.
Okay, we're definitely going to have to make an equation, and something that's going to help us to make that equation. I guess what would make it easier? You do this a lot of times whenever you have a word problem. You want to kind of take all of this and make it easier for somebody to visualize what's happening. Yeah.
Highlight the most important parts that you are gonna need for the equation, or like.
Okay, yeah, you can definitely highlight everything. These are all good ideas. I'm just thinking of something else. Yeah.
Draw a rectangle.
Yeah, I would draw a picture, okay, because the picture is going to really help to see what's happening. So what we have is a pool. That's a rectangle. So the pool is going to look something like that. And then we have a sidewalk around the pool. So it's like we have a little border around the pool, and that's my sidewalk. Okay, so this area, that's the pool. What's around it is the sidewalk. It's supposed to look the same all the way around. Mine's not perfect, but that's okay. All right, the pool is 30 by 50. So the pool is 30 by 50. And it says the width of the sidewalk is X. So that's the distance, on every side. It's X units all the way around. All right, and what's the other piece of information they give me that I haven't used? Yeah?
The area of the sidewalk?
Yes, the area of the sidewalk. Okay, I'll call that A sub sidewalk. A for area. All right, I know that that's 600. All right, well, the area of the sidewalk is a shape that basically is that purple section. I'm not going to fill it in perfect, but just so you can get the idea. That's the area, that's the sidewalk. So what I need to find, if I just temporarily move these away, is this purple section. That's what I need to find a formula for. So it's like this little strip that has 4 sides to it. Does anybody have an idea of how I could find the area of this strip inside by doing something with the big rectangle and then something with the small rectangle, that's the pool? I have to do something with those 2 rectangles to find this little strip on the outside. Yeah?
Would you find the area of the rectangle inside?
Okay, so let's even just make them different colors so we can talk about them easier. Well, that's not what I wanted. I wanted that. Let's make that. Okay, we'll just call it the big rectangle and the small rectangle. All right, so go ahead with what you were saying.
Would you get the area of the smaller rectangle inside?
All right, so we're going to need the area of the small rectangle. And what could we do with that in the area of the big rectangle? And if we do that, it would leave us with that strip in red around the outside. Yeah?
Subtract it?
Yeah, if you subtract that from the area of the big rectangle, Think about if you cut out a rectangle the size of the big one, and then you cut out the small rectangle in the middle. You'd be left with this little paper frame with a hole in the middle. That's exactly what we want to do. We want to cut out this hole in the middle and get rid of the area of that small rectangle, and you'll be left with that frame on the outside. And that's the area of the sidewalk. Now, some of these that we already know. The area of the sidewalk is how much?
600.
600. And the area of the small rectangle, well, the small rectangle, that's the pool. And the pool is 30 by 50. So how much is the area of the pool?
1,500.
1,500. All right, and now that's it for numbers. That's all we got. Now we need the area of the big rectangle. Well, the area of a rectangle is length times width. So I need the length of the big rectangle times the width of the big rectangle. And then I subtract the small. Okay, let's start with the length. Well, the big rectangle is that side in purple. Okay, that's the length. How far is it from here to there on that purple side? That's 50. How much is this section right here? Just this little part from here to here. Think about with what it lines up with up above. What does this section line up with? It has the same width as something else in the problem.
So as the pool?
This little part from here to here,
Oh, as the sidewalk.
that's the sidewalk, right? That little section right there. And what's the width of the sidewalk?
It's X.
It's X. How about this section over here?
Same.
That's the same thing. That section's also X. So what's the length of that whole big rectangle? 50 plus 2x, or 2x plus 50. Yep. It's the length of the pool plus the sidewalk on each end. That's why it's plus 2x. Now we need to do the same thing for here. What's the width of the big rectangle? 30.
Plus 2x.
Right, it's the width of the pool plus the sidewalk on each end. So 2x plus 30. And that, I think that's the hard part. That's the equation that we have to set up. Now we just have to solve it. Right, so let's start by foiling out the two parentheses so we can put all that together. What's 2x times 2x going to give me? 4x squared. What's 2x times 30?
50x.
I'm just going to put that off to the side for a second. So there's 60x. What's 2x times 50? 100x. So how many x's do I have altogether?
160.
160x. And what's 50 times 30?
1,500.
That's 1,500. But then we have a minus 1,500, which is going to cancel that out. Okay, so we got 50 times 30 is 1,500. And then we're going to minus 1,500. And that usually happens in this kind of problem all the time. Those numbers cancel out. It's just because of the structure of the problem. So now I'm left with 4x squared plus 160x equals 600. That's an equation where the highest exponent is a 2. Does anyone remember what we call that kind of equation? Begins with a Q. Yep.
Quadratic.
Yep, it's a quadratic. And to solve a quadratic, we don't want it equal to 600. We usually try to get it equal to 0. So the easiest way is I would just subtract the 600 to the other side. And one way to solve a quadratic is to try to factor it. These numbers are pretty big, and I'm not sure it would factor nicely. Does anybody remember the other method you can use to solve a quadratic if it doesn't factor? Yeah?
You split it into 2 parentheses.
So that's factoring.
Yeah.
That's factoring. We're going to try something different because I don't think that method would work on this problem.
Quadratic equation.
Yep, you're going to use the quadratic equation. So if you don't remember, let me just put that up. So negative b plus or minus square root of b squared minus 4ac all over 2a. Now, when you plug in, a is the number in front of x squared, b is the number in front of x, c is the constant. But all these numbers are divisible by something. Does anyone see what they're all divisible by?
4.
Yeah, if you divide everything by 4, it's not going to change your answer, but it is just going to make the arithmetic a little bit smaller numbers. Again, totally not necessary to do that, but it does make the numbers smaller. Okay, so this is A, this is B, and this is C. And now we just have to fill them in. Any questions on which one was A, B, and C, how I figured that out? All right. So what is negative B in this case?
Negative 40.
Negative 40. Plus or minus. B squared, that's 40 squared, that's 1600. Minus 4 times A times C. Okay, and we're going to divide all of that by 2A, which in this case, what's 2 times A? 2. Okay, before I go any further, okay, look at what's under the square root. Minus a minus. What happens when you subtract a negative?
These are fucking negative.
Yeah,
It becomes addition.
right. So you're going to be subtracting a negative. So that's going to turn into addition eventually. So I just do it right now. $150 times 4 is how much? 600. What's 600 plus 1600?
2200.
2200. Hey. Hi.
I forgot something.
Oh yeah, was it like a sweatshirt or something?
Yes.
Yeah, it's right on the back file cabinet. You're welcome. Okay, and at this step, that's our answer. We just have to type it in and see what it comes out to. So we're going to get 2 answers. Negative 40 plus the square root of 2200. And I usually do it like that. I do the top first, and then I hit divide by 2 after. I don't have to. I could have done it a little differently, but it's just how I do it. 3.45. And remember, that's just approximate. That's why I put that symbol. It's not exactly 3.45. But I still have to do the other answer. But think about this for a second. How could the sidewalk have 2 different widths? You can't have 2 different answers. So let's see what happens when we do the second one. Negative 40 minus the square root of 2200, and then divide by 2. Negative 43. Could you have a width that's negative 43 feet? No. So mathematically, negative 43 solves the problem. But in the context of the word problem, it doesn't. Okay? So the only answer here is 3.45 feet. And that's how you solve it. So any questions on how we set up the equation and then used quadratic formula to solve it?
Quick question on the, see how it says 4x squared and then plus 160x,
Mhm.
and then it turns to 1x to plus 40x. I forgot the equation we used to get that.
To get from this step to that step,
Yeah.
I just divided everything by 4
Okay.
because they made all the numbers smaller.
Oh, so you just made it small.
Yeah.
Got
If
it.
I didn't divide everything by 4, I still would have gotten 3.45.
Okay.
I just would have had bigger numbers to deal with before I got to the final answer.
I think,
So there's going to be a problem like that in the homework, except instead of a pool with a sidewalk around it, I think they have a photo with a border around it. So it's the same exact thing. The photo is a rectangle, and the border around the photo is a rectangle. But you have to do the same exact process again. Yes?
Why did you turn x squared into 1?
Because when I did 4 divided by 4, I got 1. Yeah, so when you divide everything by 4,
Oh, and then you just don't put the x in the equation?
yeah, you only fill in the A, the B, and the C. So this is what x equals. The x is like on the left side. Which I should have written it there, but I didn't. All right, let's take a look at. This one. Okay, this will be the last thing we do in this section. Okay, this is called a piecewise defined function. The idea of a piecewise function is you're drawing 2 functions at the same time. And which function you draw, usually they'll give you 2, they'll give you a rule, and they'll tell you, use this function at this time, use this function for this time. Okay? You'll see what I mean. Okay, that's an example of a piecewise function. It's 2 different formulas, and they tell you, use the top formula whenever the x is less than 1. They tell you to use the bottom formula when x is greater than or equal to 1. So this particular problem has split the domain up at the number 1. We're using a certain formula for less than 1 and a different formula greater than or equal to 1. It's kind of like if I had tickets I was selling. And I said, well, if you're under 18, tickets are $50 each. If you're over 18, tickets are $100 each. I'm splitting the domain up at the number 18. And I have different formulas for calculating the ticket price based on are you older than 18 or younger than 18. This is splitting up the domain based on are you greater than 1 or are you less than 1. So like if I was going to plug in 0, and I said to you, tell me the answer when you fill in 0 for x. Would 0 be plugged into the top formula based on the condition? Or would 0 be plugged into the bottom formula based on that condition? Which formula would 0 go into? The top one. The top one is the formula that you plug into if you have any number that is smaller than 1. All right. Now, the bottom one, that would be plugging in a number greater than or equal to 1. Like if I said to you to plug in the number 3, you'd plug it into the bottom one to get the answer, not the top one. So it's just different formulas depending on how big or small the number is you're plugging in. Any question on how I wrote that? Okay, so what I want to look at is how do we graph it? Okay, how do we graph that? It's very similar to graphing regular equations. Just slight difference. Instead of just typing in 3 minus x squared, I want you to put it in parentheses. Now, if that's all you do, is put it in parentheses and hit graph, it's going to draw the whole picture. We don't want it to draw that whole picture. I want it to stop when it gets to 1. So that means from this part down, shouldn't be there. So I need to get it to just stop. The way you get it to stop at 1 is you have to tell the calculator when x is less than 1. So in parentheses, we're going to type in x, and now we need to get the less than sign. Okay, don't think I've shown you where that is yet, so I'm going to show you. You press second, and then you press math. If you press second math, it'll bring up all your inequality symbols. We want the fifth one down. Okay, so that's what it should look like. It's going to draw 3 minus x squared, but when it gets to 1 on the x-axis, it's just going to stop. And let's hit graph. So it draws it, and then it just stops. It does do this kind of funny part that's straight on the x-axis. I can't get rid of that, but just pretend like you can't see that part. Okay, that's what it should look like. So the top one stops at 1. Where does the bottom one start? At what number?
Negative infinity.
So on the x-axis. So the bottom one stops just before 1. And the bottom one is going to start.
-2.
Well, what does the condition say? What are the x values for the bottom one?
X to the third minus 4x if x is greater than or equal to 1.
If x is greater than or equal to 1. So the bottom one is going to start at 1 on the x-axis and then continue on forever. So the top one stopped right before 1, and the bottom one is going to pick up after that. So it's going to pick up somewhere along this line. It might not connect to the old one, but it's going to start at the number 1. So it's going to start somewhere on that dotted line. Okay, so let's type that in and see what it looks like. So x cubed. I'm going to press the button below clear to get the exponent of 3. And when you're done with your exponent, press the right arrow. Because if I keep typing now, it's going to stay in the exponent. Now I'm out of the exponent. Minus 4x. And we only want to draw that when x, second math, is greater than or equal to 1. Yes? Yeah, you can just sign out. Yeah. Good. Let's hit graph. And again, it draws this horizontal part which shouldn't be there. But then it draws where it should be. So again, just pretend like you can't see anything there. And that's a piecewise function. So we got the part up to 1, and then we got the part from 1 and on. And in this case, they're disconnected, which is okay. All right, so any question on how to type in a piecewise function?
I have a different calculator. It's just giving me an error whenever I try to do with the inequalities.
What's the error say?
Syntax, just
Let me see. Did you type in?
takes you typing things up to that, and then just.
The Inspire, that one I am not 100% sure.
Yeah,
I could probably figure it out, but it might take me like 10 minutes.
Yeah, I'm gonna try to figure that out.
Yeah, it's just a little different calculator. If you want to use one of mine for now, you can, or if you want to keep playing with that one, you can. It's a little different than the ones we use. Yeah. All right. Any other questions on that one? All right. So that's called a piecewise function. And that's it for one. That was it for the last part of 1.3. All right. So 1.4. It's a review of some Algebra 1 concepts now. How to solve basic equations and inequalities. Okay. Remember, when we're dealing with a function, the general form that we use, or standard form, is y equals mx plus b. Does anybody remember what the m stands for in y equals mx plus b?
Slope?
Yep, slope. And how about the b? Yeah. The what is it? The y-intercept, yeah. So the steepness of the line and where it crosses the y-axis. So anything that can be written in the form y equals mx plus b is called a linear function. Even if it looks like this. No, that's not y equals mx plus b, but you could fix it so it is y equals negative 2x plus 3. So if you can rearrange it so it's y equals mx plus b, that is a linear function. That means when you draw it, it'll have some kind of line that's on a diagonal. Won't be vertical, won't be horizontal. Those are special cases. So it is important here, m cannot be 0. Okay? Because if m is 0, that would wipe out the x, and all you'd be left with is the b. So according to our book, yeah, no problem. You've got to have a slope there that's not 0. Any questions on what a linear function looks like? Just the equation. Okay. So I guess we can try this one. So it says, a house was purchased 10 years ago for $60,000. This year, the house is worth $85,000. So it took 10 years for the house to go from 60 to 85,000. We're going to assume that the relationship between time and the value of the house was linear, meaning that it just kept going up steady. Most things in value don't necessarily always go up. They could go back down and up, but it makes it simpler to figure out. So I want to find an equation that I can plug in a number of years, and it will automatically calculate for me the value of the house. So in order to do that, we're going to have to figure out the slope. They didn't give me slope in this problem. But what they did give me was almost like coordinates. Okay? I know that at the beginning of time for this problem, the house was worth 60,000. 10 years later, it was worth 85,000. So at the beginning of the problem, well, beginning of time in this problem, the house was $60,000. What value do you think would represent no time having gone by, like the beginning? Yeah? 0. So we're going to make a table for time and then the value of the house. when no time had gone by at the beginning, what was the value of this house? 60,000. And how would I make a coordinate with this 85,000? What do you think the next row in this table would be? Yeah.
10 and then 85,000.
Yeah. So what we basically have there are two coordinates. We're going to use those coordinates to get the slope. If you don't remember the formula for slope, well, that's the formula. It's y2 minus y1 over x2 minus x1. So let's find our slope using that. Y2 is 85,000. Y1 is 60,000. X2 is 10. And X1 is 0. Okay, what's 85,000 minus 60,000?
15,000.
That's
25,000.
That's going to give me 25,000. And what's 25,000 divided by 10? Basically just take a zero off. 2,500. Now, I didn't talk about the y-intercept too much, but the y-intercept is where the graph crosses the y-axis. One of those numbers in the table is the y-intercept. Does anybody know which number that is? Yeah.
60,000.
Right. The number with the 0 is always the y-intercept. 0, comma 60,000. So the equation of this is y equals 2,500x plus b. Now they want to know, using that formula, when was the house worth $71,250? Where would that get plugged in? Is 71,000 a t value, like a time value? Or is it like a dollar amount value? And that'll tell us whether it's the x or the y.
Dollar value.
It's a dollar amount, and the dollar amount is which letter in this case?
Why?
The y, yeah. These are my x's, those are my y's. So fill in 71,250 and solve for x. Okay. What would be your first step to solve for x in that one? Yeah.
Subtract 60,000.
Subtract 60,000, so 71,250 minus 60,000. Okay, gives me that. And what would be my last step? Yeah,
Divide by 2,500.
perfect. Divide by 2,500. 4.5, and that was years. So this house will be worth that much money 4.5 years after we bought the house. Okay, so it's just kind of a basic problem where they give you information to set up coordinates that you can use to find the slope and the y-intercept. Any questions on that? So I mentioned that there were two kind of special cases with slope. Most of the time, the slope is either positive or negative. Does anybody know one of the special slopes that can come up besides positive or negative? Yeah?
Undefined.
Undefined. And what kind of line has an undefined slope? Yeah?
Vertical.
Vertical. And there's one other special case besides undefined. Yeah.
The zero slope?
Yep, and what kind of line has a zero slope? Horizontal, exactly. So horizontal has a slope of 0. Vertical is undefined. How do you get undefined when you're doing a calculation? You try to divide by 0. Since horizontal and vertical lines are kind of special cases, their equations are also special cases. Horizontal and vertical lines are not y equals mx plus b. They're either y equals a letter or x equals a letter. Y equals is the horizontal lines. X equal, that's the vertical line. So in example 2, they're giving me the point 2, 3. And the first thing they want to know is the equation of the horizontal line that would go right through the point 2, 3. Anyone think they could give me the equation of that dotted red line? Yeah.
Y equals 3.
Yeah, it's y equals because it's horizontal. And then it's just a matter of what number do you want your line at. Well, we want it to go through the point 2, 3. So it has to be up 3. That's it. How about the equation of that blue vertical line? Yeah.
X equals 2.
Right. It has to be vertical, so it's x equals. It's a special case. And I want it to go through that point, which is 2 units over to the right. So I have to put my line 2 units over to the right. And that's it. So any questions on writing an equation of a vertical or horizontal line? Okay, and maybe if you didn't remember it, that kind of refreshes a little bit of the special cases. All right, so I kind of showed you this earlier. Y equals mx plus b, that's slope-intercept form. 2x plus 3y equals 6, that's not slope-intercept form. What would I do if I wanted to first to get the y by itself? What's the first thing I would do on both sides? Yeah?
Subtract 2x.
Okay. I'd have 3y equals negative 2x plus 6. That's when I minus the 2x. And what would be my last step to getting the y by itself? Yeah.
Dividing it by itself.
So dividing by 3. Yep. That gets y by itself. My slope is negative 2/3 x. And what's my y-intercept there?
Negative 2/3.
That's my slope.
Oh, that's your slope.
But what's my y-intercept? What is it? 2. What's the advantage of doing that? Why would I want to take 2x plus 3i equals 6 and rewrite it that way? What does this do for me?
It makes it easier to find the answer to whatever you're solving.
Can you be more specific about what it makes it easier to do? Because some things it might actually be easier to not have y by itself. It depends on what you're doing.
It's easier to find the slope, and it's easier to find the y-intercept.
Yeah, it makes it very easy to see the slope and the y-intercept, and we use those oftentimes to do what?
Graph.
To graph it. So this makes it very easy to graph now. You can graph it the other way. It's just most people are more familiar with this way. That's the main advantage. So this is another way to write the equation of a line. Okay, it's called point-slope form. I will use it when I don't know the y-intercept. and they give me a point and a slope instead of the y-intercept. It's y minus y1 equals m times x minus x1. And if we wanted, we could rearrange that so y is by itself. If you distribute out this m, you'd have mx minus mx1. And then you could add the y1 onto the end. And then you would have another equation with y by itself. But it doesn't have a b in it. That's the advantage of this one. You don't need the b. So let's see if we can find the equation that has a slope of a half and passes through the point negative 2, 3. When you use that equation, you need to fill in a number here, here, and there. So you need to fill in 3 numbers. Anybody think they know where the 1/2 is going to go? The y1, the m, or the x1? Yeah.
And
Yep, that's going to be your m. How about the negative 2? Anybody know if that's going to be the x1 or the y1? Yeah. Yep, that's the point that they give you. It's the x value. Just kind of fill these in as we go a little bit. And the 3, well, that's going to be the y1. So fill those numbers in. And that's it. So y minus 3 equals 1/2 times x minus 2. So if you were going to leave your answer in point slope form, I would just clean that up a little bit. What could I do on the right-hand side? So it's not minus, yeah.
Addition.
Yeah, we could just make that addition. And I would say that's how I would leave my answer in point slope form. If they said, write your answer in y equals mx plus b, what would you get when you distribute that 1/2 out? How about Josh, what would you get when you distribute that?
Half of x plus 1.
Half of x plus 1. Okay, we're almost there. And then if you were getting y by itself, what would be the last thing you'd have to do?
Add 3 to the other side.
Add 3 to the other side. So either answer is correct. This is point slope. This is slope intercept. I'll make it clear on the test which way you should leave the final answer. Okay. Any question on that? All right. So parallel. Okay. Parallel and perpendicular lines. If 2 lines are parallel, I know it means they never cross, but can somebody explain what parallel lines would mean using the terms we're talking about today? Yeah?
they would have the same slope but different views.
Yes, exactly. They have the same slope, but different y-intercepts. Because if they just have the same slope and the same intercept, they're not parallel. What would that be? Same slope, same intercept. Yeah?
Identical.
Yeah, they'd be the same line. 2 lines on top of each other are not parallel. Okay, so parallel, that's usually the easier one. Same slope, different y-intercept. How about perpendicular? Does anybody remember what the connection is between two lines that are perpendicular? It's just something with their slopes, and the slopes are two things. They're two things, yeah.
Negative inverse?
So they are opposites of each other. And what do you mean by inverse? Flip it, yeah, reciprocal, yeah. So when two lines are perpendicular, their slopes are opposite reciprocals. So if I had a line with a slope of 2/3, the one perpendicular would be flipped and make it negative. Those would be perpendicular lines if those were the slopes. Doesn't matter about the y-intercepts. All right, so let's see if we can write an equation of a line that's parallel to one that I give you and passes through the point 1, -2. Well, if I'm going to be parallel to that line that I just put a box around, what is it that I need to know about that line that I can't really tell looking at it the way it's written? Yeah,
The slope?
I need the slope. So the easiest way to get the slope is to get y by itself. So I subtracted the 3x to the other side. So I have -2y equals -3x plus 1. And then what would I divide everything by to get the y by itself?
-2.
Yep, divide everything by -2. So what's the slope of the line they gave me? Yeah,
-3/2. Or 3/2.
3/2. So the slope of the line they gave me is 3/2. I want to be parallel to that. So what's going to be the slope of my line?
3/2.
It's also going to be 3/2. Yep. Okay, so I know my slope to be parallel to that one has to be 3/2. And it has to go through a point that has an x value of 1 and a y value of -2. So what I would do now is just plug all those points into that formula right there. All right, so we got y minus 2 equals m times x minus 1. I'm going to leave my answer in point slope form. What's the only thing I could do to just clean it up a little bit? Yeah,
Make 2 minuses addition.
yeah, just make that addition. Y plus 2 equals 3/2 x minus 1. Okay. If they wanted perpendicular, you would have done all the same steps, except instead of using 3/2, what number would you have used right here instead? Yeah.
-2/3.
-2/3, but you would have done the same steps. Okay. Any question on that one? All right, so I think linear inequalities, yep, last thing. So when you have an inequality, the difference is you're not going to have y equals mx plus b. You're going to have y. Then you're going to have one of these 4 symbols, mx plus b. And when we're graphing a linear inequality, 2 things we got to remember. There's a solid line and there's a dashed line, or dotted. And we can shade above or we can shade below. I've made a little chart here that kind of explains when to do the shading. If you have a solid line, that's a less than or equal to or greater than or equal to. Those two symbols are the solid line. Less than and greater than, those are the dotted lines. Any kind of less than symbol is a shade below. Any kind of greater than is a shade above. The only one that doesn't quite make sense for is a vertical line. Because if you have a vertical line, there is no really shade above and shade below. Where do you think below would be for a vertical line? Yeah? Yeah, it's to the left. So I'll just put in parentheses here. You know what? Let me write it off to the side. So left for vertical, and shade above. Well, again, that would be to the right. But other than the special case for vertical, that chart will work all of the time. Let me see if I can leave that up while we do the problem. Okay, so in order to graph that, is it set up in the right format? Like, is whatever letter we want by itself, by itself? Well, what letter do we want by itself? Yeah, we want the y by itself. So Braden, can you tell me what would be my first step? Okay, so I'm going to subtract the 2x. And when you do that, what do you get?
Like 3y is less than 4 minus 2x? Or is it flipped?
Yeah, let's put it in the y, like the mx plus b order.
Oh, 3y minus 2x plus 4.
So 3y is less than, so that part's right.
Mm-hmm.
But how would you write what's over here?
Minus 2x.
Yeah. So now we've got it kind of like y equals mx plus b, kind of. All right, and what about my last step to get y by itself? Yeah.
Divide by both sides by 3.
Yep. And you have to do it there, there, and there. So we got awful numbers. They're not nice numbers. So we got y is less than negative 2/3 x plus 4/3. Okay, so we need to graph that. Well, 4/3 is like 1.3. All right, so we got our y-intercept at 1.3. And then from that dot, which way do I move to get to the next point on the line? And remember, my slope is going to tell me that. Yeah?
Down to the left. To the right.
So it is down 2, and then we're going to go.
Negative.
Remember, we want the line to slant that way because it has a negative slope.
Oh, to the right.
We have to go to the right. Down 2, right 3.
I use those.
Yeah, just a second. So it's a little messy. Let me make it so you guys can see it a little better. Okay, so I'm going to go down 2, 1, 2, and then right 3. 1, 2, 3. About right there. Okay, and we can do it one more time. Down 2, 1, 2, 3. Good enough. Okay. Now, when I draw this line, should it be a solid line or a dotted line? Yeah, this is going to be dotted because it has a less than. it says less than is the dash, the dotted line. Okay, so I'm going to get my line, make it dotted. That didn't do what I wanted. Let's try again. That'll work. About like that. Close enough. Okay, so there's my dotted line. Now the last thing I have to do is shade. Should I shade above or below? Yeah.
Below.
Yeah, this is going to be below. How come, Natalie, how come this one's below?
Because it has a less than sign.
Yeah, it's got the less than symbol. And less than always means to shade below. Right, so I'm not going to do it perfect, but you get the idea. We're just going to shade below. So right up to, but not including the line, because it's dotted. Question on that one? Okay. So we got about 15 minutes, but I think that's a good place to stop. Okay, let me double check before you write down page 31. Just give me 1 second. Okay, 32 to 36, it says find a complete graph of each function. All you have to do is tell me the window. That's it. X min, X max, Y min, Y max. 45, again, that's doing it on the calculator, a piecewise function, just find the window. And so that's the first page, 32 to 36, 45, and 50 to 52. And then page 42, that's on the lines and the graphic inequalities and shading. So that's 2, 8, 11, 16, 20, 24, 27, and 32, 44, and 77. Okay, so again, you got about 15 minutes. If you want to start anything, you can, even if you just want to open it and look at the directions and make sure you understand what they're asking or what I'm going to be looking for. You can just look at the directions and ask me any questions.